Hi, and welcome to lesson 2.3 of Precalculus. Today we're going to be reviewing along in synthetic division of polynomials. So let's look at this first example. Factor 6x cubed plus 17x squared minus 104x plus 60 completely using long division if 2x minus 5 is a factor. Well, in the same way that if I were to ask you to factor the number 35 completely, given that 5 is a factor, what you would do is you would take 35 divided by 5, and you'd get 7, and that would tell you that 7 and 5 are both the factors of 35. So what we're going to do is set up that polynomial in a division situation, just like we did with 35 divided by 5, only we're going to divide the overall polynomial by its given factor, 2x minus 5. Now, when we do this, what you're going to do is you're going to look at this outside part, and you've got your first term here, 2x, and your first term under the division sign is 6x cubed. You're going to figure out what you'd have to multiply 2x by to get 6x cubed. And we know that that's going to be 3x squared is what's going to give me 6x cubed. So 3x squared times this function, or times this expression, is going to give me 6x cubed, because that's going to cancel these out. And 3x squared minus 5 gives me minus 15x squared. And remember, at this point we're subtracting this whole binomial. So when we subtract these, the 6x cubes cancel out, and then we have 17x squared minus negative 32x squared, because we can subtract those since they're like terms. Then what I'm going to do is I'm going to bring down the minus 104x, and I'm going to do the same process. I'm going to see how many times 2x goes into 32x squared. And it appears that you would need to multiply 2 by 16x, or 2x by 16x, to get 32x squared. So if I put 16x up here, 16x times 2x gives me 32x squared. 16x times negative 5 gives me minus 40x. So remember, we're again subtracting, so that 32x squared and 32x squared cancel out. Then we have negative 104x minus negative 40. So again, that'll cause it to be minus 104x plus 40x. And I just realized a mistake I made here. This should actually be 80. If we're multiplying 16 by negative 5, we're getting negative 80, not negative 40. But still, we're taking negative 104x plus 80, and that's going to give me negative 24x. Finally, I'll bring down, just like I brought down the 104x, I'll bring down the 60, and I'm left with negative 24x plus 60. The 2x goes into negative 24x negative 12 times. So negative 12 times 2x is negative 24x, and negative 12 times negative 5 is positive 60. And lo and behold, when I subtract those two binomials, I get 0, so I have no remainder, which means my answer is 3x squared plus 16x minus 12 for my second factor. Now there's just one last thing to do, since it does say factor completely, and this can be factored further. So what we have is we have 3x squared plus 16x minus 12. If we were to factor that even more, we could separate the 16x and figure out what two numbers will add to 16 to give me my factors. So using the AC method, we'll need to figure out two numbers that multiply to give me these two, a times c, which is negative 36. And they also need to add to give me 16 so I can separate the x's out. Two numbers that do that appear to be not that obvious right away, but I'm thinking 18 and negative 2 would add to give me 16 and also multiply to give me negative 36. So we'll use 18x and negative 2x. So now I can factor this by grouping, and I get, I can take a 3x out, and I'm left with x plus 18. And on this one, I can take, or actually x plus 6, if I'm taking a 3 out. And then on this one, I get negative 2, and x plus 6, since I'm taking a negative 2 out of negative 12. So finally, when I factor that, I get 3x minus 2 and x plus 6. And don't forget the original factor that was given to us, which is 2x minus 5. So all these factors finally help me to get a complete factorization of my original function. So now it's your turn. Go ahead and try to work this out and see if you can get the three factors or two factors that are appropriate for this function. Alright, so now we're going to look at what happens when you have a remainder that doesn't end up being 0 like it did in the first example. And now we're going to look at this polynomial 6x cubed minus 5x squared plus 9x plus 6 divided by 2x minus 1. So once again, I'm going to figure out how many times 2x goes into 6x cubed, and that's 3x squared. I'm going to take 3x squared times 2x minus 1. I get 6x cubed minus 3x squared. I'm subtracting that from my original polynomial. These cancel out, and I am adding negative 5x squared plus 3x, which will give me negative 2x squared. Bring down the 9x. 2x goes into negative 2x squared, negative x times, because negative x times 2x is negative 2x squared. Negative x times negative 1 is positive 1x. And that's going to give me, when I subtract, these ones go away. 9x minus x is 8x. Bring down the 6. So then I have 2x going into 8x 4 times. 4 times 2x minus 1 is 8x minus 4. And I'm subtracting these, so those go away. 6 plus 4 is 10. So now I have a remainder of 10. But what I'm going to do with that is pretty simple. My original answer is 3x squared minus x plus 4. All I'm going to do with this 10 is add it on and put it over the factor 2x minus 1 that you were dividing it by. And that is my final answer. Just one thing you might want to specify is that x cannot equal 1/2 because that would cause that denominator there to equal 0, and we don't want to multiply by or divide by 0. Multiplying by 0 is fine. So go ahead and test your skills with this problem, which involves a remainder, and see how you do. So now here's where the fun really begins, where we want to divide x cubed minus x squared minus 14x plus 4 by x squared minus 5x plus 6. And we'll set it up the same way we have been, just like this. And we'll put the term we're dividing by over here. So same idea, first term, x squared goes into x cubed, x times x squared is x cubed, x times negative 5x is negative 5x squared, and x times 6 is plus 6x. And once again, I will subtract. X cubed minus x cubed goes away. Negative x cubed plus 5x cubed ends up being 4x, I should be saying x squared. And then negative 14x, remember this is a minus sign, negative 14x minus 6x gives me negative 20x. So then I want to do the same thing, bring down the 4, figure out how many times x goes into 4x squared, x squared goes into 4x squared, and that would be 4, because 4 times x squared is 4x squared. So 4 times x squared is 4x squared, and 4 times negative 5x is negative 20x. 4 times 6 is 24. Subtracting these, 4x squared minus 4x squared is 0. Negative 20x squared plus 20x, negative 20x plus 20x is 0. And 4 minus 24 is negative 20. So I have a remainder of negative 20. My answer up here was x plus 4. So just like last time, x plus 4 minus 20 over x squared minus 5x plus 6. And that's how I can figure out my factor for that problem. Now try this one and see if you can divide those two polynomials and see if you can get the correct result. So there's actually an algorithm that makes this long division process a little simpler, called synthetic division. And it's kind of a process we go through in order to divide just like we've been doing before, but without writing so many different terms. We can sort of simplify the process because that pattern is happening every time. Now notice there's a couple things that have to be in order for me to use synthetic division. First, I just kind of need to make sure that my powers are descending. X to the 5th, x to the 4th, x cubed, x squared, x to the 1st, and my constant. And I also want to make sure that this term over here is x minus a number. Now, the reason for that is because what we're going to do is we're going to take this term, this x minus 3, and we're going to put the opposite of the constant up in the top left corner. So if I'm subtracting, that's fine. I'll put the 3 there. But if this were to be x plus 3, I would need to put a negative 3 up here. So this is going to be my my guard kind of looking down. We're going to build a little prison here. This is going to be my prison fence. And what we're going to do is we have each of these terms is going to be a prisoner. We have 2, we have a negative 4, we have a negative 3, we have a negative 6, a negative 5, and a negative 8. Now jailbreak, the first prisoner escapes, the 2 gets outside the wall, but the prison guard over here, our 3, sees the 2 and shoots them, and they get sent back into prison. What we do when they get sent back is we multiply the 3 and the 2, and that ends up being a 6. Now these two prisoners are going to work together. You can almost say maybe the prisoner was renumbered. I don't know if you even like the prison analogy, but it's kind of just what I've always used to remember how the process works. So -4 and 6 are going to combine here and work together to get outside the wall. So -4 plus 6 gives me a 2. 3 times 2 is 6, so we put that up here. Now, -3 plus 6 gives me a positive 3. 3 times 3 gives me a 9. -6 plus 9 gives me a positive 3. 3 times 3 is 9. -5 plus 9 gives me a positive 4. 3 times 4 is 12. And then -8 plus 12 gives me a positive 4. And this is going to be my remainder. So then what I do is I take each one, it goes down a notch from what it was before. So this is going to be my x to the 4th term. This is my x to the 3rd, x squared, x, my constant, and my remainder. So when I write that, I get 2x to the 4th plus 2x cubed plus 3x squared plus 3x plus 4. And then my remainder, I can't really squeeze it in up there, but plus 4 over x minus 3 was my original factor that I was dividing by. So hopefully you've got the gist of that first example down, and I would highly recommend going back and making sure that you understand that process, and maybe even looking at the example in the book before we make it a little harder here. Because now notice our term over here is no longer x minus a number. Now we've got 4x plus a number. So what we're going to need to do is divide everything by 4 in order to get this x by itself. So that's going to involve taking each of these individual terms divided by 4. So what we're going to end up with is 8 divided by 4 is 2x to the 4th. And then 38 fourths is going to be 19 halves x cubed plus 5 fourths x squared plus 3 fourths x plus 3 fourths divided by, we've got now our regular x. 1 divided by 4 is 1/4. So now this is something that we can work with. Remember how I said you have to put the opposite of this number here up in the prison guard tower. So we're going to put -1/4 up at the top. And then we're going to put all of our prisoners in, and I'm sure you guys are going to love to deal with all of these fractions. 2 19 halves, 5 fourths, 3 fourths, and 3 fourths. By the way, it does work out, but you should check to make sure you include each power going down. If one is missing, you're going to have to put a 0 in. Say there was no x squared term here, you would need to put a 0 in for that x squared term. So making our prison fence, first number is always the one to escape, and then we multiply -1/4 by 2 to give me -1/2. When I add these together, I get 18 halves, which is 9. 9 times -1/4 is -9 fourths. 5 fourths minus 9 fourths is -4 fourths, or 1. -1/4 times -1 is a positive 1/4. 3 fourths plus 1/4 is 1. And again, -1/4 times 1 is -1/4. 3 fourths minus 1/4 is 2/4 or a half, and that is my remainder. So cascade your powers down, you get 2x cubed now plus 9x squared minus 1x plus 1 plus 1/2 over what we were dividing by, which is, in this case, x plus 1/4. Remember, we use the synthetic division to divide by x plus 1/4, not the original function. So x plus 1/4 goes here. That's a lot of fractions to deal with, so why don't we multiply the top and bottom by 4, and then we end up with a final answer of 2x cubed plus 9x squared minus x plus 1 plus 1/2 times 4 is 2, and we get 2x. I'm sorry, that's actually 4x on the bottom. We should get 4x plus 1 in our denominator, and I would just make the x not equal to negative 1/4, because that would give you 0. So go ahead and try out synthetic division on this example and see if you can come up with the right answer. Alright, so we can know whether or not a binomial is a factor of a polynomial if when we divide that binomial, when we divide the polynomial by the binomial, we get a remainder of 0. That's how we know that they're factors. So what we can do quickly to determine if x minus 5 and then x plus 5 are factors of this polynomial is we can use synthetic division. So for the first one, let's put 5 up here, and when we're taking our polynomial, we have 1, negative 18, 60, and 25. And when we put our fence down here, the 1 comes down. 5 times 1 is 5. Negative 18 plus 5 is negative 13. 5 times negative 13 is negative 65. And then that's 5. When you add them, 5 times negative 5 is negative 25. Add them and we get 0. So x minus 5 is a factor. Let's check out x plus 5 by putting a negative 5 up here. So we have 1, negative 18, 60, and 25. Put our fence up. 1 comes down. Negative 5 times 1 is negative 5. Negative 18, and negative 5 is negative 23. Negative 5 times negative 23 is 115. 60 and 115 gives me 175. And then negative 5 times 175 would be negative 850. Or 875, and then when I add 25 and negative 875, I get negative 850. That remainder is definitely not 0, so x plus 5 is not a factor of this polynomial. X minus 5 is, however, a factor. So what we could do is we could use this to develop our two factors. One is x minus 5. The other would be x squared minus 13x minus 5. So to kind of summarize our ideas behind synthetic division and remainders, if r is the remainder that we get after dividing f of x by x minus c, then r is the value of f of c. So the remainder is what we'd get when we put c into the function. Also, if the remainder is 0, then x minus c is a factor, which we determined in that example. If the remainder is 0, then the value c is an x-intercept of the graph of f. And finally, if the remainder is 0, then x equals c is a solution of f of x equals 0. So I just want you to try one last question before we conclude. See if you can use the factor theorem to determine if the binomial is x plus 2, which would be the first answer, and x minus 3, which would be your second answer, are factors of that overall polynomial f of x. Now, if you have any questions, go ahead and feel free to let me know.